to open the terminal, all you have to do is just go to your all applications and then just search for it. Say terminal, and there you go. So this is your terminal and this is the command line interface, so you can just type on it. Now the language that we are going to be using to communicate with the kernel through the shell is called bash, also known as born again shell. Now bash is based on sh, and now we have more evolved version like the Korn shell, also known as KSH, and the Z shell, etc, etc. Now you don't have to worry about it. These are just basically the evolved version, so they just added more commands, more features to the previous version. So all of the commands that we're going to be using will mostly work on any shell. You will find like more commands, more features on the improved shells. Now say for example, if you are using a Mac OS, and Mac OS, now previously the bash was the default scripting language for the terminal, but then now they are recommending Z shell because they have added like more features and more commands to the scripting language. Okay, so you just don't worry about it. The things that we are going to be using over here will mostly work on any terminal. Now here you will notice that there is an @ and before the @ is your username, and after that is your machine's name. Okay, and then there is a $, and before the $, there's a tilde. So this indicates your current directory. So whenever you see this tilde sign, basically you are in the user's home directory. Okay, now every time you will try to execute any command using this command line interface, it will be referred from your current directory. So right now the $, the tilde before the $, indicates your current directory. So whenever you see this tilde sign, that means you are in the user's home directory, not the root directory. You have to remember. Okay, now from the previous video you have seen the Linux file structure, the file hierarchy. So basically you are over here. Now this was our root folder, our root directory, but now we are not here. We are basically in the user's home directory, which is this one. So we are basically over here. Okay, now how do we know that? To know that, you can simply type pwd, which means print working directory. You click enter and then it will show you that the first slash indicates the root directory, and then the following slashes are basically the separators. So it's the root slash and then home, that means in the home directory, and then another slash, that, and then within that home directory there's a directory called Taj, and then I'm inside that. So this is now my working directory. So if we type pwd, which stands for print working directory, we can see that where we are at right now. Okay, so we are basically, so slash means root and home, and then over here. Okay, nice. So now let's first see how to navigate around the operating system using this terminal. So to do that, first we want to see that the contents of the current directory, right? So we write ls, and when you hit enter, you will see all of your contents within that directory. As you can see, that is the same thing. See, all of these directories are shown over here. So that means we are in this directory, and now in our graphical user interface, to enter a directory, we can simply just double click, right? Say for example, I want to go to the pictures. I can just double click it, and then I'm into that directory. So now here we cannot double click, obviously. We cannot just like double click over here. It does nothing. It's a command line interface, so we have to give command to the shell. So let's do this. So to change your directory, you have to use something called cd, which means change directory, then space the directory name. So right now I'm trying to access the pictures. So pictures, pictures. Now one thing you have to remember when you are working with Linux operating system, that Linux is case sensitive. So if you put pictures like this one, it won't work. Okay, you have to be precise with the cases. So it is case sensitive. However, in Mac operating system, it's not case sensitive. So there's this small difference between the terminals in the Linux based operating systems and the terminals in the Mac operating systems. So in the Linux, these are all case sensitive, so you have to write exactly the way it is written. Okay, so that is you have to keep in mind when you are working with either Linux or Mac OS. Okay, so by cd we can change the directory. So we hit enter. Now as you can see, there's the $sign, and the left part of the $sign says pictures, which means now I am inside that directory. Okay, whatever written on the left side of the $sign, I am within that directory. So again, if I need to know the full directory, the full path, I can simply see pwd. So now you can see previously it was just home/taj, and now it's home/taj/pictures. Now to see the contents of the pictures directory, we can simply again do the exact same thing we did over here, ls. By hitting ls, you can see that there are two contents. One is the Firefox_wallpaper.png and another one is wallpapers. So basically, if you look over here, we have a wallpapers directory and a file named Firefox_wallpaper.png. Now the terminal will color code you the type of files accordingly, because right away you have no idea of which one is a directory or which one is a file. Right now you can say that okay, there is a extension, so you can just simply look at the extension, but however files can exist without extension, so you have to keep in mind. Okay, so so wallpapers is another directory and this is a file. So as you can see, those are in different colors. Okay, now we can again go to enter the wallpapers directory by simply saying cd space wallpapers. Again, it's case sensitive, so be careful. Wallpapers, and now as you can see, the $sign left part says wallpapers. That means we are in the wallpapers directory. Okay, so this is how we can enter a directory and then browse the directory basically. Okay, now how do we go back? So in the user interface, we can just simply click the back button to go back, right? But here there's no back button. So how do we go back? So to go back, you have to say cd space then double dot, okay, or full stop, whatever you say. So cd space then double dot. If I hit enter, now as you can see, the left part of the $sign says pictures. That means I am in the pictures directory now. To go back further, I have to do the same thing again, and now as you can see, it only says the $sign. That means we are within the user's home directory, and we can check that by saying ls. So we're in this user's home directory. Okay, now so we just learned how to navigate around the file structure. So now let's see how we can create directories and files. So first, let's see how to create a directory. Now in the user interface, you can just simply right click and create new folder to create a new directory. However, in the command line interface, you have to write mkdir, which means make directory. Okay, so mkdir then space, you have to name your directory. Say for example, I want to say new one. Okay, if I hit enter, you will see that in the graphical user interface, I have a new directory, and we can also verify it from over here. Just simply typing ls will show us that the new directory has been created. Now that we have created a directory, now we want to see how to create a file. So I want to create a file inside that new one directory. Okay, so first let's say cd new one. So now we are within the new one directory. Now whatever we do will be referred from this directory. So we want to create a new file. Now we can do that in two ways. So we can either use the cat or the touch. So I'm going to show you how to do it using the cat. So cat is basically concatenation. So you say cat, then this sign, and then space the name of your file. So let's say it's a.txt. So hitting the enter will not get you another line with a dollar sign. That means you are still within this command. Okay, so now you write whatever you want to write in that file. So I want to say hello CSC 321 peeps. Okay, so I hit enter, and well, it just went to another line. So basically we're still in this command, we're still in this cat command. So we can write another line, say for example say the typical hello world. Okay, now we're done. So now we want to exit this command. So to exit any command from the command line interface, from the terminal, all you have to do is just hit Control and Z, which is Z basically, not G, is Z. Okay, so Control plus Z will get you out of any working command. So we were working on this cat command. So we were writing these lines, and then when we were done, we just hit Control and Z, which just will get us out of this command. Okay, so this works for basically any command that requires you to manually get out using your computer, using your keyboard input. Okay, so let's see. So we have created this a.txt. So let's see if it is created or not. So ls. Now as you can see, yes, we are in this new one directory, and within that new one directory we have a file called a.txt. Now if I want to view this file in my graphical user interface, so it's created in new one. So I just go to new one, and then I can see that there is a file called a.txt. So double clicking it will open the file, and as you can see, the lines that we have written are present over here. That means we have successfully created a file and written something to it, right? Okay, so now that we have seen how to create a directory and how to create files, let's see how to manipulate the files, modify, which is basically copying, moving, and deleting the files. Okay, now to do that, so let's so now I have this a.txt file in this new one directory. So let me create another directory. Let's call it new2. So ls. So as you can see that there is a.txt, and then there is new2. Okay, now I want to copy this file, copy this a.txt file to this new2. So all I have to do is just write cp, then space, and the name of the file. So cp space the name of the file, which is a.txt, and then space the destination where I want to copy this file. So I want to copy this file to this new2 directory. So I write new2. So basically cp, which means copy, then space the file that I want to copy, and space the destination where I want this file to be copied. Okay, let's hit enter, and so it should copy this a.txt file to the new2. So if we hit ls, we can see that okay, this a.txt file still exists. Okay, then we will just use the cd command to redirect to this new2 directory. Now we are in new2, and let's hit ls, and as you can see that this new one had this a.txt, and now this new2 also has this a.txt, which means we have successfully copied a file from one directory to another. Okay, now let's see how to delete a file. To delete a file, the command is rm. So rm space the name of the file. So the name of the file is a.txt. So rm, which is remove, then space the name of the file. So if I hit enter, okay, it should delete the file. Let's see, ls. See, there's no more. The file is no more, which means the file has been successfully deleted. So this is how we can copy and then remove a file. Now we can also move a file. So let's see. Let's just go back to our new1 directory. So new1 should have this a.txt file. Okay, now we want to move this a.txt file to new2. So to do this, we write this command mv, which means move space the file that we want to move, which is a.txt, then space the destination, similar to the copy command. So cp space the file we want to copy and where we want to copy it. So when we want to move the file, mv space the file that we want to move and space the destination where we want this file to be moved. Okay, so the destination should be new2. So let's see what happens. Okay, it should move the file. Let's see ls. See, now ls no longer shows this a.txt file, which means it should be moved. So let's check that too. So cd new2. Okay, we're in new2, then ls, and as you can see, the new2 directory contains this a.txt file, which means that this a.txt file has been successfully moved from new1 to new2. So this is how we can also move a file. Okay, so far we have removed a file using the rm command. So now I want to remove this directory, this new2 directory. Okay, so now if I do the same command, so rm then new2, something interesting will happen. You see, so it says that it cannot remove because rm2 is a directory. Now to remove a directory, we have to use a special argument for this rm command, which is rm then dash r then space the name of the directory. So every time we want to remove a directory, we have to use this special argument called this dash r. So now if I click this, see, no error is given. So if I do this ls command, and as you can see, this new2 doesn't exist anymore. So if I go to the graphical user interface, so as you can see, this new one is empty. Now the reason we have to use dash r or hyphen r is because the normal rm command basically is used to remove the single file. Okay, but however a directory can contain multiple files or even multiple directories. So to remove all the files, we have to use a special argument dash r, which stands for recursive. So we are basically asking the shell to recursively remove every item that is inside this directory. So whenever we are going to remove a directory, we will have to use this rm then space hyphen r and then space the name of the directory we are trying to remove. Okay, this type of arguments are not exclusive to just rm. Like you will also find different arguments for different commands. So like for example, the mv that we use to move files between directories. So say for example, when we were moving in Windows operating system, we usually see that there is a prompt, like if there is already a file with the exact same name, that if I want to override the existing file with the newer file or not. So if we want a similar type of prompt, then we can just simply use this -i and then use the command, which is source and then your destination. So this way, if we use this -i, then the command line interface will ask us that if a file already exists with the exact same name, then it will ask that if I want to override the file with my source file or not. And then there are other arguments, like there's something called u, which will basically replace the destination file only if this source file is newer than the destination file. Okay, otherwise it will just skip it. So now almost like most of these commands already have different arguments that do different that provides different options for the user. Now, how do you basically know that uh, which which argument does what, and which commands even have this type of arguments in the first place? So to know, you don't have to memorize it. Okay, there is a very easier way. Now, in the shell, there is something called manual, which oh sorry, there's something called, let me remove this. So there's something called man. Okay, so man space, then you write the name of the command that you are trying to learn. So say for example, I want to know that what type of arguments are available in the RM, or say for example, I don't even know, I forgot what this RM does. Okay, I just remembered this command, so I want to know that, okay, what this RM does. So all I have to do is just say man space, then the name of the command, which is RM. Now this man stands for basically manual. Okay, so this will give us the complete manual or the documentation for this RM command. So see, now as you can see, it defines that what this command does, and then the description, and then the available options. See, all the arguments that are available. So as I have discussed, so I used R. So as you can see, it's for recursive. So it's for removing directories and the contents recursively. See, so you don't have to memorize these arguments, or even the I mean the description on, and what does this command is basically used for. So you can always just look it up in using the man command, and it will just give you the whole documentation for that specific command. Okay, now you can just use this, then you can press this Q button to quit. So pressing Q will just return you to the main interface. Now let's try another thing. So let's try ls. Okay, so if I see ls, so see, it is used for listing the directory content. So here, if you look, that this ls command also have some arguments, right? Now let's look at some. If you notice over here, if we use the -a, it will show the directories which starts with dot. Okay, then let's see, what does it even mean? So let me quit it now. So we used ls. Okay, fine. Now this new one directory is basically empty, so let's just go to our previous directory over here. So ls showed us all the directories which we could see on our user interface as well. All right, cool. Then so let's try this -a. Now you can see that it has a lot more contents than we could see before. So these are new, see, starting with dots. So what are these basically? Now you should be already familiar with the Windows hidden file system. You can just simply hide a file. In a Unix based system, both Linux and Mac OS, everything that starts with dot is considered a hidden file. So anything, it could be a directory, it could be a file, doesn't really matter. If it starts with a dot or a full stop at the beginning, then it will be considered as a hidden file. So the OS will not show it. Okay, see, our user interface were also not showing it. Now if I press Ctrl H, as you can see, all of these files also exist in our graphical user interface as well. they weren't showing because the OS was considering them as hidden files. Okay, so by pressing Ctrl H again, it will hide those files as well. Okay, now in the beginning we could see two more things, right? A single dot and a double dot. So remember, to go to the previous directory, we were using this double full stop or double dot cd space dot dot. Is because this dot dot refers to the previous directory. So basically this dot dot is referring to the previous directory. Now when we were at new one, it was referring to this directory, which is this one. Now, so every time you are in a directory, this dot dot refers to its previous directory, and this dot, the single dot, refers to the current directory. So this dot means that is the current directory, double dot means the previous directory, and all of these are the files and directories that are available within this directory. And we can also use this ls command to find a specific content within our current directory. So if we do, say for example, I want to list all of the contents that starts with D. So I do it like this, ls then D and asterisk. So this way everything that starts with D and asterisk mean I don't care, whatever is on the right side. Okay, it should start with D. So let's see. So as you can see, it has found desktop, documents, downloads, because all of this starts with D. Now it will also show the contents within that directory. So downloads have this directory, so sorry, this file, so which is also being showed over here. Okay, now we can also do something like, say I want to find the contents that starts with DO. So the first one should be D, the second one should be O, and then the later one I don't care. Okay, so by doing this, see, it's documents, it's downloads. Again, it's also showing the content. Okay, now we can also do something like, let's say I want to see whatever that is ending with an S. So asterisk X. So whatever on the left side, I don't care, but it should end with an S. So as you can see, documents, downloads, pictures, templates, and within that pictures directory, we have one file and one directory. So it's also being showed over here. Or we also have videos. Okay. So now you will find more stuff, more examples in the material PDF, which will be provided. So you will notice one thing, that it is very similar to the regex pattern. So you can use this pattern to specifically find your file or the file types that you are looking for. Okay. Now we will learn about the security system in the Linux based operating system. There are three security groups in a Linux operating system. First one is the user or the owner. So whoever creates a file, he becomes the owner or the user of that file. So he will have certain permissions, and then some permission can be assigned to a group, and all others who is basically not a user or not in a group will have different permissions. So what are the permissions that can be given to each of them is like, first one is known as R. So this permission is called the read permission, which is represented with the letter R. Whoever has this read permission can open the file, can see the content of the file. However, he will not be able to modify the file. To modify the file, he will need to have another permission called W. So this W permission is basically the write permission. So if someone has this permission, he will be able to make changes to that file. And lastly, there is X. This X permission is basically the executable permission. So if someone has this permission, he will be able to execute that file. Now in Windows we have exe.exe as the executable files, but here Linux, as I have stated earlier, that Linux basically handles everything as a file. So it doesn't really know if a file is executable or not. So this permission, this X permission, can be assigned to any file. Okay, now the way it is written, say for example, I'm talking about this a.txt file. So a.txt file that we had. Okay, so say for example this a.txt file. Let's see. So the way it is written, say for example, the user created that a.txt file and he has all this permission. So it will be written like this: first R, then W, and then X. Remember, the sequence is very important. So it's always going to be RWX. It's not going to be WRX or XWR. This sequence is fixed. First is the R, then is the W, and then is the X. Say for example, the group has this read permission. Okay, fine. This write permission, but the group does not have the executable permission. Okay, so the group cannot execute that file, provided that it's an executable file. So the way this will be written is like just a simple dash. So RW and dash, which means the group has read access, the group has write access. However, the group does not have any executable access. That's why dash. And say for example, for all others, for all the outsiders, they only have this read access. They cannot change the file. They cannot modify the file. So they don't have this write access. So dash, and they don't have executable access as well. So another dash. Now this will make more sense in when we will go into the examples. Now let's look at an example. So let me bring up the terminal. Okay, so there's a special ls command, which is ls with an argument of -l. So if I do this, it will give me the contents of that directory with a lot more information. Okay, now the beginning part is the security part. The permissions that are given to each security group can be understood from this part. Now it doesn't make much sense now, but we'll go through it. Okay, so we have a file which is a.txt and some directories. So let's first focus on the directory. So let's see the desktop directory, and we have this. Okay, so let me write it over here. So we have D, R, W, X, R, dash, X, R, dash, X. Okay, now we will slice this like this. So first this part, and then following 3 letters, and then following 3 letters, and like this. So the first part indicates the type. This is the type. So this D means it's a directory. As you can see, it's a desktop is a directory. For files, as you can see in a.txt, it should be just a dash. Now there are some others, like for example, semaphore will give you S, and there are lots of other notations for different types of files. Okay, so mostly you'll see directories with D and files with just a dash. So the first part indicates the type of the file. The following three letters are for the user group. So the user or the owner group. So this part is for the user. So see, we can see this RWX. So the user has read access, write access, and executable access to this file, to this desktop directory. The following three parts are for the group. So this is group. So group has write access, read access, no write access, and executable access. Okay. And the last part is for the others. So others can read, cannot write, can execute. Okay. So similarly, for this a.txt file, the first one is dash, so it's a file, and then rw and dash, which means user has read access, write access, but no executing access, and then the group has read access, write access, again the group cannot execute, and then the others can read only, others cannot write, cannot execute this a.txt file. Okay, hopefully now it all makes sense. So we can understand which security group has which permission from this beginning part. All we have to do is just write ls and -l. Now how to change the permissions? Okay, now there are two ways you can modify the permissions. One is the symbolic mode and another one is the absolute mode. So first I will show you the symbolic mode. So let me adjust it. Okay, so to use the symbolic mode, you have to use the use the command, which is chmod. So chmod, then space, you write the letter for the corresponding security group, which is U for the user, G for the group, and O for the others. So say for example, you want to add write permission to the group, so you do this first group and then you want to add write permission, so plus write permission, which is W, so chmod space G plus W, then space to which file you want to do this, the name of the file. So say for example I want to do this for this a.txt file, so it's a.txt. I'll hit enter. Okay, now let's run this again, ls-l. Now as you can see, okay, so it already had write permission, so let's add something other. So let's add execution permission. Okay, so I'm adding execution permission to the group. So let's see. So as you can see, this group, which is the group's permission, has been updated, and now it has R, W, and X, which means the group now has execution permission as well. Okay, now let's see what we can do. So let's revoke this read permission from the others. Okay, so to revoke a permission, all you have to do is chmod and then the group that I'm trying to modify is the others, so O, and then previously we used plus to add a permission. Now to revoke a permission, we are going to be using minus. So minus, and then so we are going to take away this read permission from the others. Okay, so minus R. So I'm taking away this read permission, space, and a.txt. txt. Hit enter and then ls dash l. Now as you can see, all of the other users permission is dash dash dash. That means previously there was only R and I have revoked this R, so now it has nothing. And another thing you can do is you can like overwrite permission. So we are adding using the plus. So whatever we are using, whatever we are plusing with is just adding another permission to the existing permission. But if we want to override the permission, the whole permission, say for example, for the group, I want to override it with only write permission, nothing else. So I will do this chmod. The group will only have the write permission, nothing else. So equal R. So the equal sign will overwrite the every other permission and only keep the permission that I am writing over here. So like a.txt. So when we use the plus sign, it was adding a permission to the existing permission. When we will use this equal sign, it will just overwrite all of the permission and only keep this permission. So if we see this, so as you can see, now it only has R and W and X are gone. You can also assign like multiple permission at a time. So say for example, you want to add write permission and execution permission at the same time. So chmod z group and it will have write and execution permission for a.txt file. So let's see. As you can see, so R and X both are assigned. So R and X. See? So equal will just ignore the previous, all of the previous permission, and then will only allow the current permission that are given, and plus will add the new permission on top of the already existing permissions, and minus will revoke a permission. Okay. And there is another way to set permission, which is the absolute mode. Now to use that, we have to learn something new. Okay. So we know that there are three permissions. So R, W, and X. In absolute mode, each permission has a corresponding number. So for R, it is 4. For W, it is 2. For execution, it is 1. So say for example, you want to assign all three permissions. So you want to assign read, write, and execution permission. So you do. So all you have to do is just add these values. So 4 plus 2 plus 1, which is 7. So you're basically adding all of these values and then just use that value. So 7 stands for all of the permission because 4 plus 2 plus 1 is 7. Now say for example, now you want to have just the write and just the read and write permission. So you add 4 plus 2, which is 2 is 6. And say for example, you want to have the write and execution permission. So you just do this 4 plus 1, which is 5. So 5 means just write and execution. So all you have to do is just add those numbers and then you can set the permissions accordingly. So, and if you want to assign a single permission, then just use the single number. So 4 stands for just write, 2 will be for sorry, 4 for read, 2 for write, and 1 for execution. Now let's see how to do this. So again, you have to use chmod space and the corresponding values. So say for example, this a dot will modify this a.txt. I want all of the permissions for this for the user. So it will be 7. Then I will have to define all of the permission. Okay, then I have to define the permission for the group. So now I don't want all of the permission. I want just the read and write, okay, which is 4 plus 2, which should be 6. So 6, and say others will only have this write permission. So 4. Then the name of the file a.txt. So you have to write like this. So chmod, then space, then all the numbers. Remember, whenever you're using the absolute mode, you have to modify all of the security groups permission at a time. So it is useful whenever you try to like modify the permission for everyone. Okay. Otherwise, if you want to just permission for a single security group, just use this the symbolic mode. So you just define one, and then you can also assign multiple permissions to the multiple groups with a single line, but it will require you to write a lot more than just like this 3 single digits. Okay, so it's much more convenient whenever you are trying to modify the permission of all of the security groups at once. So I'll hit enter. Now if I do this, so as you can see 7, so all of the permission, 6, 4 plus 2, so r plus w, yes, r plus w, and 4 only r. So these are the two ways you can use to assign to modify the permission of any file in a Linux operating system. Now we will learn about the links. So what is a link in Linux operating system? So you are already familiar with shortcuts in Windows, right? So link is something similar. Now a link can be of two types. Okay, so we have link. So one can be the soft link, and another one is hard link. The soft link is also known as the symbolic link. So the soft link is basically like the shortcut in Windows operating system. So say for example, you have a file. You have a file a.txt, and you just make a shortcut. Now this shortcut does not contain any content of the original file. It just links it. So you have a file at, say for example, in your documents, and you don't want to go to the navigate to the documents and every time open that file from document, right? So all you have to do is just create a shortcut and then put it in your desktop, so that you can just log into your computer and directly click on the shortcut, and the shortcut will then identify the actual file, will locate the actual file for you and then open it from the original source file. So softlink is basically like the shortcuts in our Windows operating system. So we're all familiar with the shortcuts. We have video games or softwares installed in a C drive or D drive deep inside the program files and whatnot. And we have the shortcuts present in our desktop so that we can easily access it. The shortcuts will be basically like 40, 50 kilobyte depending on the icon size, and then but in the actual file is much larger than that, because those file actually contains the real contents. Shortcut is just the link. So soft link is something like this. So you create a soft link and it will be just the it will just contain the destination of the original file. That's it. And whenever you click it, it will open it from the original source file. Now hard link is different. So in hard link, so you have again the same file a.txt and you have a hard link. So you have a hard link. Whenever you create a hard link, the contents will also be carried over to the shortcut. So that's the difference between a soft link and hard link. So whenever you are creating a hard link, all of the contents from the original source file will also be available in the linked file or the shortcut file. Now you may ask, then isn't it something similar to like the copy? We can just simply copy the a.txt file and have another file. So we can just have all of the contents copied over to another file and then we can just put it wherever we want, right? So then why do we need hard links? We can simply copy a file. Well, to understand this, we will have to dive a little bit deeper into the file structure, the file hierarchy system of the Linux, which I have discussed earlier, the FHS or file hierarchy standard. So if you remember that we had first we had the root, right? The slash, the backslash, and from that we had like what we had bin, we had home, we had sbin, etc., etc. And inside the home we had a user and then some directories. So we have created new one, and here we had like the a.txt file, and within this new directory we had another a.txt file, right? So this was our hierarchy, the tree. Now the way Linux manages this hierarchy is not by the name of the files or the directories. Linux doesn't care what the name of the file is or whatever inside that file is, because as you can see that this is a.txt is also over here and over here. So the same file name, the same file can exist in multiple directories and multiple hierarchy. So how does it identify each file? Well, it uses something called the inode. So the inode stands for the index node. So each file has its own inode and a unique inode, and this inode has a number and has some corresponding metadata, so where the file is, when the file was created. However, it does not contain the name of the file and the content of the file. So it's just like the metadata of the database that the Linux is maintaining for this file hierarchy system, file hierarchy standard, sorry. So each of these file has its own inode number. So say for example this a.txt has this 303 inode number and this one has 304. So different inode number for different files, even though the content is the same, the name is the same, Linux doesn't care. So we have different inode number for different files. So whenever we're making a copy, so over here we have copied a.txt and a.txt, the same file. Say for example, if we copy this same file, we will have different inode numbers. That means the OS will treat those files differently. However, whenever you do the hard link, if say for example the original file had this inode number of 404, then if you create a hard link, it will have the same inode number. Now, what does that even mean? So now that they have the same inode number, the operating system will treat those files equally. So as a result, whenever you modify one file, say for example, you're modifying this file, the changes will be applied to this file as well. Which is not the case for copying. So hopefully now you understand the difference between the soft link and hard link, and the difference between the hard link and simply copying a file. So now let's look at an example. Let me first go to the new one. Okay, cd new one. Okay, so now I am in this new one and I have nothing over here. So let's create a new file, a.txt. Say we have something. So now we have a.txt. So let's create some links. So first I want to create a soft link. So to create a soft link, you have to use the command ln. So ln space, then for soft links you have to use -s, then the original file, which is a.txt, and then the name of your shortcut file or your link file. So let's call it b.txt. So b is basically the soft link of the a file, a.txt file. Okay, let's hit enter, and if we look at the graphical user interface, as you can see, we have A and B, and as you can see, there is a sign. So like similar to Windows, you will find a shortcut sign on the shortcuts from your desktop. So you will see similar sign over here. So now B is basically a soft link version of the A. So this is basically opening, even though it's opening a b.txt file, it is basically opening from the original source file. Okay, so now we have B, which is the soft link version of the a.txt file. And now another thing we can do is create a hard link. So to create a hard link, for the hard link you have to use ln, then just a.txt, the source of the file. So you don't need any argument for the hard link, so you just write it as it is, then space. Say for the hard link I want it in c dot txt. Okay, so c should be the hard linked file of the a.txt. So let's see in our so now we have another thing called c.txt. Let's see, now it doesn't have this shortcut sign because it's a hard linked file. And now if I open c.txt, I'll see the content of the a.txt file. Similar content, right? Now all I want to do is, let's just modify this file, okay, from the c.txt file, and let's see if it changes this a.txt file or not. Say this is a modified file. So we are modifying the c.txt file, which is the hard link of the a.txt file, and we're saving it. Okay, so we have changed the c.txt file. Let's close it, and now let's open the original file. As you can see, this a.txt has also been modified because these are hard link A and C. Okay, so hope you guys understand. Thank you so much.